All right, so in this problem, we are asked to figure out all the trig ratios for the ordered pair 12/13, 5/13 on the unit circle. All right, so here we have our unit circle, and we know it's a unit circle because the radius is 1 unit. And the ordered pair 12/13, 5/13, that point would be right here. So 12/13 is almost 1, and we can see that if we're looking at how far this is over, it's almost to the 1. And it's 5/13 of the way up. 5/13 is a little less than half, and if we look at this point here, it's a little bit less than half. So this point here is 12/13 over and 5/13 up. And if we draw the triangle from the center of the circle to that point, and then we connect that point down to the x-axis, and we go back to the center here, we get that triangle. And this triangle has a length on the bottom of 12/13, and that makes sense. It's 12/13 over, and it has a height of 5/13. And right here, this will be a right angle right here. And over here, this would be the hypotenuse because it's opposite the right angle. So the trig ratios here, sine, cosine, and tangent, they are the ratios of the sides. So if we call the angle made right here theta, the sine of theta means we are talking about the side that is opposite theta, so 5/13, and over the hypotenuse of theta. So we're taking the ratio of this side over the length of this side over this side. All right, now I'm just going to circle all those lengths of the sides so they're easy for us to refer to. All right, so SOHCAHTOA is something you may have heard before. It's how I remember what the ratios of the sides are. Somebody had taught me that, and it stuck with me. So sine is the ratio of the opposite side over the hypotenuse, or the sine of theta is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So if you can remember SOHCAHTOA, then you will remember what those ratios are. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now the inverse trig ratios are cosecant, which is the inverse of sine. That means instead of opposite over hypotenuse, we flip those. It's hypotenuse over opposite. Secant is the inverse of the cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And cotangent is the inverse of tangent. So let's go ahead and fill these in here. All right, so for the sine, we have the opposite over the hypotenuse. So if this is theta, the opposite side is the side that is opposite it, so that's 5/13. And we're going to divide that by the hypotenuse, and the hypotenuse is 1. And that cleans up to just be 5/13. Now cosecant is the inverse of that. So now we're going to flip it. So this is going to be 13/5. For the cosine, we have the adjacent over the hypotenuse. So remember, cosine is adjacent over hypotenuse. So adjacent means the side that is attached to, or the leg that is attached to that angle there. Adjacent means next to. So 12/13 is the adjacent side, and we're going to divide that by the hypotenuse, which is 1. So that cleans up to 12/13. And the inverse for the secant is going to be 13/12. And the last one here, opposite over adjacent for tangent. So tangent is opposite over adjacent. So the opposite is 5/13. And the adjacent is 12/13. So we have 5/13 divided by 12/13. Okay, and you may remember that when we are dividing by a fraction, it's the same as multiplying by the reciprocal. So some people prefer to do this like this. Instead of dividing by 12/13, we'll multiply by 13/12. And then we can clean this up, and this simplifies to 5/12. Okay, and then the inverse of that would be 12/5 for cotangent.